Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is semiconductors, diodes, and transistors. These tiny components form the backbone of modern technology, powering everything from smartphones to medical devices. To understand semiconductors, we first need to look at materials based on their electrical conductivity. Some materials, like metals, allow electric current to flow freely, while others, like rubber or glass, do not conduct electricity at all. Semiconductors fall somewhere in between. They have properties of both conductors and insulators. This unique behavior makes them invaluable in the field of electronics. Semiconductors are usually made from elements like silicon and germanium. These materials do not conduct electricity well under normal conditions. However, by introducing specific impurities into them, their electrical properties can be controlled. This process, known as doping, allows semiconductors to be transformed into two types, one with an excess of free electrons and the other with a shortage of electrons, creating holes. This brings us to an important application of semiconductors, the diode. A diode is a simple semiconductor device that allows current to flow in only one direction. It consists of two regions, one rich in electrons and the other rich in holes. When connected in the right manner, the diode conducts electricity. However, if the direction is reversed, it blocks the current, acting as a one-way switch. When a forward voltage is applied, meaning the P side is connected to the positive terminal and the N side to the negative, the depletion region shrinks, allowing current to flow. This is called forward bias. However, in reverse bias, where the P side is connected to the negative terminal and the N side to the positive, the depletion region widens, preventing current flow. This unidirectional behavior makes diodes essential in rectification, which converts AC to DC. Apart from simple PN junction diodes, we have special diodes like Zener diodes and light-emitting diodes, LEDs. Zener diodes allow current to flow in reverse beyond a certain voltage, making them useful for voltage regulation. LEDs emit light when current passes through them, widely used in displays and indicators. Now, let's discuss transistors. A transistor is a three-terminal semiconductor device that acts as a switch or an amplifier. It comes in two types, bipolar junction transistor, BJT, and field effect transistor, FET. The BJT consists of three layers and is classified into NPN and PNP types. In an NPN transistor, a small current at the base controls a larger current between the collector and the emitter. The PNP transistor works similarly but with reversed polarity. BJTs operate in three modes: cutoff, active, and saturation. In the active mode, they function as amplifiers, while in saturation and cutoff, they act as switches. On the other hand, field effect transistors, or FETs, use an electric field to control current flow. The most common type is the metal oxide semiconductor FET, MOSFET, which is widely used in microprocessors and power electronics. Unlike BJTs, MOSFETs require very little input current, making them more efficient in many applications. Diodes play a crucial role in rectification, the process of converting alternating current into direct current. This function is widely used in power supplies, chargers, and electronic circuits. They also serve in LED technology, where they emit light when an electric current passes through them, making LEDs an efficient and widely used lighting solution. Doping is the process of adding impurities to intrinsic semiconductors to alter their electrical properties. When we add elements with extra electrons, like phosphorus, we get an N-type semiconductor, which has free electrons as charge carriers. Conversely, adding elements with fewer electrons, like boron, creates a P-type semiconductor, which has holes as charge carriers. Now, let's move on to diodes. A diode is a two-terminal semiconductor device that allows current to flow in only one direction. It consists of a PN junction, formed by joining a P-type and an N-type semiconductor. This junction creates a depletion region, a zone devoid of free charge carriers. Now, let's move on to transistors, one of the most revolutionary inventions in modern electronics. A transistor is a semiconductor device that can amplify signals or act as a switch. It consists of 3 layers and can control the flow of current in a circuit. Transistors have changed the way electronic devices work. Before their invention, bulky vacuum tubes were used in electronic circuits. Transistors replaced them, making electronic gadgets smaller, faster, and more efficient. They are found in almost every modern electronic device, from radios to microprocessors in computers. One of the key applications of transistors is in amplification. A weak electrical signal can be fed into a transistor, and it will emerge as a stronger signal. This is why transistors are crucial in devices like hearing aids, speakers, and communication systems. Another vital role of transistors is in digital circuits. They function as tiny switches that can turn on or off rapidly, forming the basis of binary logic used in computers. Every digital device, from calculators to smartphones, relies on millions or even billions of transistors working together seamlessly. Semiconductor technology has revolutionized the world, leading to advancements in medicine, space exploration, and artificial intelligence. The ability to control electricity at such a microscopic level has paved the way for innovations that shape our daily lives. As we conclude this discussion, it is important to recognize the significance of semiconductors, diodes, and transistors in modern technology. These small yet powerful components have transformed the way we live, communicate, and interact with the world. Thank you, keep exploring, stay curious, and continue your journey of learning with AskPrep. Best of luck with your NEET preparation, and see you in the next lesson.